medical world was rocked with the extraordinary image of a laboratory mouse affixed to a human ear. Seemingly overnight, the ability to engineer body parts in a lab revolutionized the field and opened our eyes to a new and exciting world of possibilities. Today, state-of-the-art advancements in the field of tissue engineering and regenerative medicine are helping patients with unique needs to grow organs and bone material with their own cellular tissues.
The emergence of scaffolding technology actually arises from the need to develop some kind of a semblance to normal bone tissue. And this started somewhere in the early 1990s when some researchers and clinician scientists coined this term called tissue engineering and regenerative medicine. The whole idea is to steer the clinical community towards adopting a regenerative approach to healing, because a lot of the technologies are based on replacing existing bone loss.
Tissue engineering has three components, with the cells, the growth factors, and the scaffolds. And in order to produce the scaffolds, we use a 3D printing technique to create a microarchitecture. But once it's ready, we'll have to input the cells and the growth factors. The surgeons will extract bone marrow from the patient's hip.
Cranial synostosis is a condition where the bone plates in the child starts to fuse prematurely. So the joints between the bone plates have got they fuse at a different age, and very often in normal children it will be about 2 years old. But in cranial synostosis, this fusion starts much earlier. If you do not treat it and is allowed to fuse prematurely, the pressure goes up, and then the effects will be on the brain.
From a patient standpoint, I think that tissue regenerative technology in the form of bioresorbable implants need to be an option. In the past, permanent implants such as titanium, Medpor, nylon, Supramed, these were the gold standard. They have stood the test of time, they are readily available, they have a long track record in craniofacial reconstruction. But nowadays, bioresorbable implants need to be an option because they provide certain advantages that permanent implants don't.
So what's especially significant about this technique, where we endeavour to have the patient regrow their own missing tissue, in this case bone, is that the reconstruction and the devices that are used in the reconstruction become part of the patient. So there are no or fewer issues related to long-term retention of prostheses. The implant, for example, is designed to dissolve over the space of 2 to 3 years, leaving in its place the patient's own bone, which they've regrown themselves.
When the doctor explained to me that this foreign object that they're using actually melts away over time and then replaced by their own bones, it was quite fantastic to see how technology have improved. And I was happy that there was no foreign object that will be in them permanently. So that was a relief.
I came to my senses out of my coma by around the end of February or March in 2019. When I came out of my coma and could recall what was going on, my uncle explained to me what had happened, that I'd been in a motorbike accident overseas and I had to have 2 craniectomies where my skull had to be removed. I also was not able to walk and I'd lost a substantial amount of vision. It was a lot to contend with, having 2 holes in both sides of my skull. The second cranioplasty, where the 3D print went into my head, I had to have a skin flap put over that side of my head. Around 7 or 8 months after the surgery, the skin flap got removed, and it has been confirmed that I do have skull regrowing in my head now.
I had made plans to go to my dad's on the Sunshine Coast, and by the time I got off the train, I had to ring her and just say, "Mum, I don't think I'm able to walk. It really hurts to take a step." Obviously, when something like that happens, you have a million things going through your head, but at no point did I think it was cancer. That just never popped into my mind. And then when I met Dr. Waggles and the orthopedic surgeons, they presented me with a lot of different options. It's been about a year now since I had the surgery, so that's kind of crazy for me to think about. All this time I've been healing, and now I'm back at school and I crutch around almost everywhere, and this year has definitely been the hardest year of my life, but it's also been the best. I have grown so much and I've been exposed to so much that has just changed my life for the better.
Everything feels okay. I live with comfortable life.
The last patient, Miss Nadia, came to us with a very badly deformed orbit. What I mean that is the eye socket where the eyeball is badly displaced. Sadly, it had been repaired elsewhere and the implants were not in the right place. So that resulted in the eye being shifted way back inside. She wasn't able to move her eyes and obviously was not looking normal. Ordinarily, in these patients, we would have gone in to go ahead and replace the implant, but after taking out the original implant, re-breaking the bones as it was soon after the injury, and then do multiple stage reconstruction. What made this particular implant different was that we were able to print, design an implant specifically for Nadia so that we didn't have to do all the traumatic surgeries the second time around.
I can go out now, and previously I cannot go out because my eyes very droopy and feel pain.
So what makes all these modern surgeries possible is technology. And I think medicine can only go so far without technology. And that is what has completely changed medicine in the past 10, 15, 20 years. And we are now in the era of personalized medicine, where every patient now has a specific drug of a specific dose or a specific metabolism that they have. Likewise, all these surgical problems nowadays ideally will be treated with specific implants crafted for the one patient.
Regenerative medicine from here on will continue to gather interest and gather steam as we have more widespread adoption of this technology. Also, as patients ourselves become more educated with technology, we are also expecting more in terms of the healing process. So I think that we will continue to see a good uptake in this technology. And as a regenerative implant company, we aim to be always at the forefront of this technology age, and we want to continuously develop more solutions, not just in bone, but also in other areas of tissue reconstruction, and continue to push the boundaries of what the clinicians can use as a surgical option on their operating table.
Osteopore, leading the science of sustainable surgical solutions. For more, visit osteopore.com.